My name is Brent Curdy.
2 weeks after.
I'm a fifth-year PhD student at Duke, and my talk today is about Area Revisited, and it's looking at variance in people's ratings of concepts. Throughout the conference so far, we've had a lot of talk about like different identities that there's places in EPA space. We've talked a little bit about behaviors and modifiers and emotions and this kind of thing. But for my research, I'm looking, kind of taking a step back, if you will. I'm looking at how people are rating towards like the raw data. I know in the Bayesian stuff we're talking about covariance matrices. It's basically that data, the raw data that we're getting. A lot of this we've talked about, and everyone will be familiar with, of course, but affect control theory really depends on the cultural expertise assumption. That is to say that when we give a survey to people to gather the EPA ratings, we try to give it to people who agree a lot. We don't want like a lot of variation. We're trying to find cultural consensus. People are rating things similarly. To do this, we distribute the survey usually like to college students, or in the old days like to high school students, places where culture was being generated. The idea being that those people, if English is their first language and they've lived, say, like in the U.S., and then they know like what the EPA of like a doctor would be. You wouldn't want to ask somebody who's from another culture because that's not going to tell you about the U.S. culture. So these like deciding where we're going to field the surveys to collect these EPA things. This is like a priori assumption of cultural expertise. Like we're giving it to people who we think are cultural experts. There's another way we kind of make sure they're cultural experts is post hoc ways. Like after the fact, we'll do a Q analysis and see if someone rating something completely different than everybody else. Then we'll say, well, maybe that person wasn't a cultural expert. And the goal here, of course, is to avoid too much error. We want people to agree as much as possible. We want to kind of hone in on that mean EPA. But nevertheless, there's still variation. Even if we're targeting college students, even if we're doing analysis after the fact, there's still variation. This here is actually the most agreed upon in the evaluation dimension in the most recent data set. Child molesters, everyone agrees they're the worst. But in potency, and these are all scaled to the same size. So the bars are small, these are size here. But they're kind of all over the place in how potent they want to say a child molester is, and activity similarly. The next slide we have, this is a dishwasher. So they're like typically positive, but like, and by the way, I have this is their scores, and like this is their EPA rating. We would say 1.92 for a dishwasher, which would be right about here. Even though looking at the modes, we would have neutral. So I mean, you can see that people are rating like on where a little bit, like a lot. They're kind of pulling up on where the ticks are in the sliders. But okay, and there's another example. Homeless person. Here we have a clear mode at neutral, so that's kind of reflected here in the EPA. But the point is, you can see there's distribution. There's spread. So people have looked at this variation. The first paper that, to my knowledge, that's done that was Heiss's mining error variance. And he found that people of different genders, people with different upbringings, that they tended to rate some terms differently than people of other genders. Similarly, Amy's study, she found that like conservatives and liberals tended to rate some terms differently, based on their political ideology. And then Weisskopf's dissertation found that sociodemographic variables predicted that people would rate terms differently based on their sociodemographic status. All of these things, though, their focus is on what it is about the people that they're not agreeing. But what I would like to do is right here. Well, what I'd like to do is kind of change the focus of the question of what is it about our raters that they're not agreeing, and say maybe it's something about the concepts that the concepts aren't conducive to a mean rating. Like in other words, the variance may well be part of the concept itself. The mean, by the way, explains 60% of variance. I basically regressed try to see how much the mean explained in this variance. Explains a lot for evaluation, but gets less, of course, activity. Always the odd man out there. Yeah, this is the point. And where I'm going with this is that the error variance is patterned. Yep. So I'm saying this a lot of order here, but yeah, the difficulty is figuring out like who is it that's just not paying attention to a question, just answering maybe randomly, and who is answering differently from other people, but it's a meaningful difference. So figuring out whether measurement error is a property of the term or a property of the respondent, so to speak, this is kind of a difficulty. But there is actually theoretical precedence for trying to figure this out. One of them comes actually right out of Tice here, where he identifies 4 sources of measurement error. He says that there's comprehension error. People might not understand a word, and so that person, since they don't know the word, they'll rate it differently. People might not remember what a word means. Judgment error, maybe they read a word, they read mother, but they are thinking of like a Catholic mother or something. People are basically misunderstanding the word. And then response error, like maybe people are afraid to go to the ends and this kind of thing. But again, all those are things that's wrong kind of with the rater. But you could think of them as also think of them as qualities of the word. Like if somebody can't think of what a word means, it could be because that word is difficult. Or if they can't retrieve it because it's difficult. If they think of like they read mother and they think of all these different mothers, it could be like that word is just not clear. It has a lot of different meanings. Today, because of time constraints, and I'm still working actually on one of my operationalization of these, I'm going to focus on the comprehensions like word difficulty. And then the other source is, we've talked about a lot this conference, is institutionality. That identities especially have institutional affiliations with them. Like that's the quality of the word, not necessarily something that people are bringing into it. It's just like a word, like police officer is associated with a law dimension. It could be people really agree on things when it comes to I can't say a lot, like maybe family, but they really disagree when it comes to like religious identities. Or maybe those just have a lot of variation in them. Or maybe there's more difficult words in the business institution, etc. So my hypothesis then is that this error variance will be patterned both by how words or where words are at in institutionality, and also by how difficult a word is. My data come from also Mechanical Turk. This is the rating of the 2015 MTurk dictionary. The one that I'm looking at today, actually we asked more than 936 different identities, but because I made a mistake when I was fielding my study, I forgot to have a condition mixed in there. Anyways, I'm looking at 936 of those identities. Anyways, but the whole data set though had, actually this is still, I think still just the ones I'm looking at. Anyways, a lot of ratings. Each respondent or each concept was rated about 100 times. So we have a lot of ratings. Then for my for my institutions and my difficulty, I actually fielded also to MTurk, but to different people actually. Although apparently on MTurk, just so you guys know, once someone's participated in your study, you can send just those people's studies again in the future, kind of like as a panel type situation. I didn't do that here. I was trying to get my data fast, so I just sent it out. But I got about 10 ratings for each concept because there's a lot of concepts and I only had so much money. So anyways, this is yeah. All right, I want to look at these are the standard deviations of all the identities in the MTurk dictionary. Basically, what I'm showing you here is the idea that if people really agree, if people tended to have be really close, very closely to each other, we would expect the standard deviation to kind of be piled up on one side and to have like a negative binomial distribution. But instead, we see a normal distribution of standard deviations. Yeah, that's 11. This is a scatter plot here of where how positive or negative an identity was rated, how positive or negative, and then how much people agreed on it based on the standard deviation. we can see that people, like down here, we have child molester. So there's low standard deviation because like people really agreed on it, but it's also super negative. Up here, I don't remember which one that is. We'll just say that it's like hero or something like this. Really positive, and people agree. Low standard deviation, people agree that it's positive. But then we notice this kind of arc shape here. There's only a few neutral identities. Basically, as an identity has a neutral evaluation rating, it's standard. It's because this would suggest it's because people are disagreeing about it more. And we have a potency activity here. We have a kind of a similar pattern, but it's not quite as pronounced, at least visually. What is this? Okay, so this is my dependent variable. It's effectively, I just took instead of taking the standard deviation, which is variance squared, thanks, John. Instead of using the standard deviation, I just used the absolute difference from the mean. In other words, if the mean is like 2 and someone rated it 3, then that would be a score of 1. Or if it was 2 and someone rated it only 1, then that would also be a score of 1. Like they're 1 off, in other words. So this is like how many times and how far people are off. So here we have about 2,000 times where a rating was 1 off. Okay. This is this is one of the slides I threw in after I was here, just to show that like goodness and badness aren't equally distributed in EPA space in the news dictionary. We have blue, right? Blue is like are the positive identities, so they're like rated not negative. So in evaluations, they're positive identities, and we can see that most of like the law category are positive. Family, they're mostly positive. Business, mostly positive. Only in the lay institutional category we have more negative than positive rated identities. And similar pattern here with the other dimensions, where we have most like sex, religion, politics, medicine, that all tend to be rated as more positive than negative, or more active than inactive identities. All right. Let's see. This is the number of identities I have from the coding. We can see that we just have fewer identities in these categories. And part of this is kind of a sample. I don't want to say bias, but it's a result of sampling. Like if we could just like kind of brainstorm more academic identities to fill up these categories. But in what we asked, this is what we have. Okay, well, I kind of move through this to my results. These are examples of. These are just like random. I just ran a random number generator and chose 4 random identities out of each category just to show as an example. Down here, and there is also the indefinite. Indefinite is where people chose these identities in more than one of the domain categories. So like female makes sense, scientist. All right, word difficulty. These were what's rated as the most difficult words. I actually had 4 levels of difficulty, but there were so few of the hardest ones, and I did my analysis both ways, and I found that I could just collapse the 4th into the 3rd. So there's 3 difficulty categories. Hardest words, housebreaker, half-wit, killjoy. They seem to make, at least looking at them on the surface, they make sense. Suppose biologists over here. Anyways, difficulties. Okay. So this is some of my results. So this is the absolute differences by domain. So people had the fewest differences from each other in medicine. People really agreed about medicine identities, really agreed in the evaluation domain, really agreed how good or bad academic identities were. And they mostly disagreed about the evaluation mentioned for religion, politics, and then this is these are in the same order, but and I obviously ordered these here for the evaluation domain. But people still agree on the potency of medicine and generally about academia, but disagree on the potency in romance, and it's still higher in politics and religion. They're similar to each other, but so you can just see the patterns here. And this is for activity dimension. They're kind of yeah, it's just different patterns here. I'm happy to talk about this. Then moving quickly because I'm almost out of time. Word difficulty. I just predicted word difficulty and how how far people were from each other, how off they were. And I found in all of them, and remember there's actually a lot of ratings because I'm using individual ratings, so there's like a lot of them. So the statistical significance was always like, 0.0001, so that was really good. But I then controlled, just to make sure, I controlled for education. And so I'm going to interpret this one here really quick. Basically, the more difficult a word is, the more likely they were to be far away from, or different. So as it got harder. And that's even for controlling for education. And basically, the reference category here is less than high school. So as people, so the more education you got, they're all negative. Meaning, the more education you have, the more likely you are to rate things similarly. But still, where difficulty matters. If something's harder, people still be different from each other. Okay, so this is just my summary here. Some domains have more dreams than others. And really what this means for affect control theory is I guess how, if variation is a meaningful dimension of affective meaning, then I'm not sure. I have a few ideas of what to do about it, but nothing that I have on the slides here. I think it's possible we could. I wonder if I guess I feel Bayesian ACT is probably a solution to a lot of this. If we could have confidence intervals around means, so we can basically know that we're more confident in a mean and what if we know what dimension it's in. As of this morning, Dave, when he suggested the superposed states, the idea that some identities, like people have multiple identities that will collapse down once an event happens. It's like I was like, I think that's a great idea. But you can also take that straight up to the raw variations and be like, yeah, people disagree about what a police officer means, or what a mother means, or what a dishwasher means. But in an event, people coalesce into me. They're like, that's the EPA for that identity. So that's oh yeah.